Good afternoon, ladies and gentlemen, and welcome to our online event on carbon metrics and budget. The aim is to gain a better understanding on how to measure and manage mitigation of the built environment. We are lucky this evening. We have 4 distinguished speakers. The first one is Professor Thomas Lützgendorf, who is Director of and Chair of the Institute of Sustainable Management and Housing and Real Estate at Karlsruhe Institute of Technology. Thomas' work focuses on life cycle analysis and integration of sustainability aspects and methods and tools of the property industry. Thomas' presentation will be followed by Dr. Marcela Saheb presentation, who is a researcher at Technical University of Graz and member of the working group on sustainable construction at the Institute of Technology and Testing of Construction Materials. The focus of her work is on life cycle inventory generation, dynamic modeling of carbon cycles, and impact distribution in multifunctional processes. Marcela's presentation will be followed with by Tina Fawcett's presentation. Tina is leading the policy and governance team at the Center for Research on Energy Demand Solutions, and she is also acting director of the Environmental Change Institute Energy Program at the University of Oxford. Tina uses a multidisciplinary approach to understand current patterns of use and to identify opportunities and policies for reducing energy demand and carbon emissions. Last but not least will be the presentation from Maria Balutsky, who is senior researcher at the Center for Real Estate at Karlsruhe Institute of Technology in Germany. And the focus of her work is on life cycle impacts of building to sustainable urban development at different scales. After these 4 presentations, we will have a Q&A session. I invite the audience to write their questions in the right-hand side on Brilla platform. And then to end the session, Richard Lorch, who is editor-in-chief of Buildings and Cities Journal, and who was previously the editor-in-chief of Building Research and Information Journal, will give us a summary of the session and key points for going forwards. And before starting this, before giving the floor to Thomas, I will first give you an overview of what we mean by greenhouse gas emissions of the built environment and where do we stand from Paris Agreement perspective and perspective. So I will share my screen. Implications of the Paris Agreement temperature target. As you know, the Paris Agreement, what is specific about it is the fact that it introduced 2 thresholds for the temperature target that we should aim for the end of the century. And following the Paris Agreement, 3 years later, the IPCC, the Intergovernmental Panel for Climate Change, published a report known as IPCC 1.5 degree target, which clarifies what does that mean to be at 1.5 degree target. What do we mean by greenhouse gas emissions from the built environment, or what are the greenhouse gas emissions included in the built environment? In reality, we have CO2 emissions, CH4 emissions, N2O emissions, and F-gas emissions. But in practice, we have data with high confidence or low uncertainty only on CO2 emissions at global level. Emissions from CH4 and N2O exist for the EU and North America, but there is high uncertainty on this data. And then F-gas emissions do not exist at the sectoral level. They exist all together. That's why when we talk about greenhouse gas emissions in the built environment, we basically end up working only on CO2 emissions. It does not mean that other emissions do not exist. It's just that at this stage, they are not available for the built environment. And these data are consolidated in IDGAR database, which is a database run by the Joint Research Center of the European Commission. And in terms of emissions in the built environment, we have three different types of emissions, or three different scopes of emissions. Scope 1, which is direct emissions. So for example, it would be emissions from the use of gas boilers in housing. And these emissions exist at a global level, and we have high confidence in the emissions that we have, the data we have. And then scope 2 are indirect emissions. Indirect emissions include heat and power generation, which is taking place outside the buildings, but which is driven by the energy demand of buildings. These data exist as well at global level. However, these data are calculated. So we may have we still have discussions between different experts doing this kind of calculations. The third scope of emissions are embedded emissions. These are the emissions that are embedded in construction material, and it should also include emissions in all the goods that we have in our buildings. Unfortunately, this set of data is not available for all construction materials. At this stage, IA makes available only emissions from steel and cement, and we don't have all other emissions. We don't have data yet, especially when you look at global level. We may find sometimes at national level, some countries have this data, but at global level, they do not exist yet. When we look at emissions of the built environment, so basically, as I showed, so most of the emissions, when we talk about greenhouse gas emissions in the built environment, in reality, we have data only on CO2 emissions, except a little bit for the EU and North Africa, North America, where we have data on CH4 and N2O. These emissions have been increasing over time. So this data from 1990 to 2018, we don't have a decrease of emissions. And we don't have decrease because of the global emissions, or the national emissions from the built environment, and then the global ones, because in the meantime, this period is the period of development in the global south, changing economies and growth. This means that we have more square meters that have been built during this period, but also in the global north, we don't necessarily have the same number of square meters built in the global north than in the south during this period. However, we have more under-occupied houses, for example, and we have aging population and different societal changes that increases the CO2 emissions from the built environment. And what is interesting is to look at the built environment compared to overall CO2 emissions. And when you look at this, you realize that CO2 emissions from the built environment represent at least 35% of the global CO2 emissions. I say at least because, as I mentioned earlier, embedded emissions that we have for which data are available are only related to cement and steel, and we don't have embedded emissions for other construction materials. Now, what does that mean from Paris Agreement perspective and from global carbon budget perspective? And what are the implications of the implementation of the Paris Agreement on the built environment? So the Paris Agreement introduces two thresholds for temperature. The aim of the Paris Agreement is to be below 2 degrees by the end of the century, and aiming for 1.5 degrees. And what the IPCC 1.5 report clarified in 2018 is the carbon budget allocated, that the remaining carbon budget for each of these two temperature thresholds. And based on this, considering the contribution of the built environment to the global emissions, then we can calculate the global remaining carbon budget for the built environment for the period 2018-2050. And following that, we can estimate the number of years that we have ahead of us to be able to decarbonize the overall global, built environment, actually the global built environment. And we see that we are between 12 years, 12 and a half years, and 35 years. So really we are running out of time, and the built environment is running out of budget. And this is why this session, the session of today, is really timely, because it will help us understand what is the best way to be within this threshold in terms of timing, while decarbonizing the global built environment.